Hey guys, I thought I'd just make a quick video around the VO2max data analysis prac. Last year I did make a VO2max data analysis template, which was a lot more intricate and in-depth, but last year we had a lot more time to go through it, which is complicated this year. So I've simplified things a little bit, but at the same time you guys aren't losing on any of the depth of the analysis. It's just the details linking to the template that I've changed. So to make things a little bit easier with your analysis, I'm going to kind of just guide you guys through it. It's a lot simpler, but it just lacks a little bit of the precision, I would kind of argue. So in order to answer your post-lab review questions, um, you'll need the Prac 2 guide, which technically speaking is Prac 1 for this particular module, but there are specific criteria for your gas exchange threshold, specific criteria for your respiratory compensation point, and specific criteria for your VO2 max. Okay, so you'll need to take these into consideration when you are answering your questions. Just remember, with the final heart rate value, please use this specific formula. That might be of some importance a little bit later on, rather than the simplified 220 minus age. Okay, so I'm just going to give you a sample dataset. This is not the same dataset that I gave you guys. Remember, VT1 in this particular scenario is your gas exchange threshold. VT2, or your second ventilatory threshold, is your respiratory compensation point. And then obviously you've got VO2 peak. Let me just make a little bit more space there. Okay. For each of these inflection points, you'll have to write out the absolute VO2, the absolute VCO2, the relative VO2, the velocity associated with those inflection points, heart rate, the VE-VO2 ratio, the VE-VCO2 ratio, the minute ventilation breathing frequency, PET O2, and PET CO2. Okay, so for example, the V-slope method is where you plot VO2 on the x-axis and VCO2 on the y-axis. It looks something like this. So what you can do is just hold the shift button, press the right button, then press Control, Shift, and down. It'll highlight all the cells associated with those columns. Then go to Insert and Scatter Plot. Okay, just if you don't have the 2016 version, just follow the same steps, but just find the scatter plot in your version. Okay. It will then draw it without the requisite labels for the x and y axis. We'll have to add those in, so I'm going to do that quickly. So once your actual graph is highlighted, go to the Design tab, then go Add Chart Element and Axis Title. The primary horizontal axis we said was VO2, so you can just highlight that and delete it. Press VO2, and that's in this case liters per minute. Then we do the same thing, add chart element, axis title, primary vertical. Again, I can just type it in here, that's VCO2, and that's also in liters per minute. Press enter. Okay, so now at least we've got labels and we know exactly what is what. Here I'm trying to identify the gas exchange threshold using the V slope method. Okay, that's what I'll put as my axis, my chart title, sorry. Alright, so we need to find a specific inflection point, and we should be able to see, if we just kind of visually observe this, there's some kind of a breaking point in and around here. And we're going to try and at least get the best possible estimate using the tools that we have at our disposal right now. I'm going to go to Insert, and then over here, Shapes. I'm going to insert a straight line. So I'm going to draw a kind of like a line of best fit to these early data points here as best as I can. And this is a little bit of an eyeball. Coincidentally, this is how it's traditionally done. I don't really like this method because eyeballing lacks precision, and what I tend to eyeball might not coincide with what you tend to eyeball. But again, you'll need to validate why you've identified a specific inflection point, and that's one of the reasons why I've made you guys include your specific graphs. Okay, so I'm going to try and again just get these early data points over here with a line of best fit. I'm going to then draw a line of best fit for these later data points. Also make that black, and just keep adjusting it up and down until you are satisfied that that's more or less a good fit for your data. Alright, so you can see here where these two lines intersect. I'm going to just kind of, whoops, let me not draw that. Let me insert a new line, and I'm going to draw a straight line down over here. And I'm just going to change that color to orange so it stands out a little bit, and then I'm going to draw another line that intersects with the y-axis and make that orange as well. So now what you want to see is if this is the point of intersection, which it's not quite. I'm just going to move that over there a little bit. You can see here that the x-axis value, the VO2 value that coincides with this inflection point, is just shy of 2 liters per minute. And the VCO2 value that coincides with that inflection point is give or take on 1.5. So what you're going to have to do now is go to this original data set here and find where 1.5 for VCO2 and just shy of 2 for VO2 is found. So just shy of 2 on VO2 would be around about here, and then around about a 1.5 give or take is what we're looking for. So this looks like a fairly good candidate. I'm going to try and scroll a little bit further up and see if there's any other ones where I have a 1.5 for VCO2 and a just shy of 2 for the VO2. There's a 1.55 and a 1.88, and that's separated by give or take 10 seconds. I'm happy with this one for now. So what I'm going to do is going to highlight that entire row and just color code it yellow so it really stands out. So if that is the inflection point that I choose, and remember there's multiple criteria that I might have to draw more than just one graph. If that is the inflection point that I choose, then I'm going to use this 1.86 and 1.5 value, and I'm just going to put it in here. So this is 1.86 for VO2 and 1.5 for VCO2. The relative VO2 is over here, so that would be 27. That's what I'm going to write in there, 27. The velocity associated with that, I'm just going to go all the way across here, and I should find it in this column over here. So it's 5.8 kilometers per hour. I would round it up to the nearest whole number, so that's 6 kilometers per hour. And then the heart rate associated with that is 124 beats, and so on and so forth. You just keep filling in all these values. Okay, so remember to copy and paste this entire graph into your answer. Okay, so I can follow along with why you chose a specific point and all the values that are associated with that. Okay, the next one is to find out or to see if you can determine your respiratory compensation point. There's essentially two ways that you can do that. One is to use your VCO2 on the x-axis and your minute ventilation on the y-axis. So I'm just going to show you guys how to do that quickly. And then, whoops, minute ventilation. I'm going to go to insert and again a scatter plot. I'm just going to move that down so it's a little bit clearer. This is respiratory compensation point using VE and VCO2. So remember, the thinking behind this is that at a secondary inflection point, the minute ventilation tends to increase disproportionately relative to the VCO2, the carbon dioxide that is produced. So remember that at a certain point, the amount of carbon dioxide that's produced due to the lactate buffering tends to cause a disproportionate increase in the minute ventilation, where you actually start hyperventilating. So you can kind of see it's not as clear as this inflection point over here, but there is a secondary inflection point that we can see a little bit later on. So we go through the same process. I'm just going to insert some straight lines and try and get a line of best fit as best as I can. And again, I'm rushing through it a little bit just to give you the rough idea. You guys are going to take your time. And then I'm going to insert another one. So once I insert these lines, you can start seeing those inflection points a lot more clear. Oops. and that's the whole point of this. You want to be as accurate as possible. I'm going to make that a black line. Good. All right. And again, I'm going to just insert the point where it intersects. So try and get as good of a value as possible. Just make sure it stands out again. And another one up here. Okay. So you can see here for, again, I must add these labels. So let me just do that again quickly. Insert chart element. The x-axis was VCO2. And again, that's in liters per minute. And the y-axis is minute ventilation. And that's also in liters per minute. Perfect. Okay, so you can see here that the minute ventilation is just over 80, and the VCO2 is probably give or take 2.6. So the x-axis, so the VCO2 is about 2.6. That's what I'm going to try and look for over here, or as close as possible. So 2.6, and then the minute ventilation, I'm just going to move this out the way. So give or take a 2.6, and again that's still in the way. Let me just move it down a little bit further. Say 2.6 and close to 80. So maybe where we at, just over 80. So that's already too high. So around about 80. Maybe my point here. Oops. Okay, I can see that that's been moved around a bit. Again, just make sure that your data is as accurate as possible. So you can see that's actually a little bit higher. Okay, so maybe closer to 90 and about a 2.6, give or take. So let's just see. It's about 2.6, and that's about a 90. So this looks like a good candidate for now. And again, I would write down all these values that are associated with that point. So VO2 and VCO2 for the second one is 2.68, 2.59. 2.68, 2.59, and the relative VO2 is 38 moles per kg per minute, so on and so forth. And again, you complete that, and then the same process for VO2 peak. So remember, VO2 peak is, I'm going to plot, I think in your guys one, I put time here. So you're going to plot time and VO2. And you can use the relative VO2 to plot that. Oops. Let's do that again. Come on. There we go. Insert, and then again scatter plot. And you can see here, this would now be my VO2max analysis. And again, you'd have to label the y-axis, which would be your VO2, and label the x-axis, which would be your time. In this case, it's time in seconds. And again, it becomes difficult to really identify if this is a plateau in the VO2 max, in the VO2 uptake, and you'd have to use several criteria to identify whether that's truly a VO2 max or just a VO2 peak value. Okay. So again, you'd have to justify which values you've ascribed with your VO2 max or VO2 peak, and heart rate, speed, RER, so on and so forth that is associated with that. So be sure again to include that graph in your answers. And I think that's pretty much it. So be sure, like I said, to complete this to the best of your ability using the process that I've just kind of shared with you guys in this video. And again, like I said, if you don't include the graphs, I can't give you the points associated with those questions. So please, please, please include those graphs. Thank you so much.